Hello everyone. Once again welcome to MPLS series. Guys, today we are going to talk about inter-autonomous MPLS VPN option B when we have multiple link between ASBR routers. In this scenario, you can see between router 4 and router 5 we have multiple link. So this is third video of option B configuration. In previous video we discussed option B with next hop self and redistribution method, and today you will understand how to configure inter-autonomous MPLS VPN option B when we have more than one link between ASBR routers. See, configuration on router number 9 like CE routers and router 1, 2, 3, 6, 7, 8, 11 and 12. These routers configurations are exactly same like previous video. So here I have already configured these all routers, and between router 4 and router 5 we are going to configure eBGP, because as you know, whenever we have multiple link like between router 4 and router 5, today we have multiple link, so we will configure BGP between router 4 and router 5 through loopback interface, because we have multiple link between router 4 and router number 5. Okay, and here we need to configure eBGP multi-hop as well, because loopback to loopback, the number of hop is more than one, loopback to loopback. So that's why there are some extra configuration as well. There is some configuration of MPLS. Today we are going to configure static label binding. This is the first time we are going to configure a static label binding. You will understand why we need to configure it and when, on which router, and why we need to configure it. Okay, after that we will see the configuration and packet flow. Don't worry, first of all let me configure BGP between router 4 and router 5. Here is the console, and you can see router number 1. On router number 1, router 1 should receive customer A side 1 and side 2 prefix in their BGP table. So BGP VPN v4 unicast all. You can see here we have this two network. Okay, and router 1 will advertise it to their neighbor, to router 2. So on router number 2, so BGP VPN v4 unicast all. So router 2 have also these two network in their BGP table, these two VPN v4 prefix. After that, router 2 is going to advertise to router number 4. On router number 4, I have already configured BGP neighborship between router 2 and router number 4. Only we need to configure BGP between router 4 and router number 5. I have not configured anything between router 4 and router number 5. So on router number 4, if you will check BGP table, so BGP VPN v4 unicast all, it should receive these two prefix, side 1 of customer A and side 2 of customer A B. Okay, so router 4 have these two VPN v4 prefix in their BGP table. In the same way, router number 5 will have these two, 192.168.2.0 and 172.16.2.0 in their BGP table. So let me show you the BGP table of router number 5 also. Okay, so BGP VPN v4 unicast all. So here also you can see. Okay, and we don't have any VRF on router number 5, so IP VRF. In option B we don't need VRF. On router number 4 also, so IP VRF, we don't have any VRF. First of all, I am going to configure BGP between router 4 and router number 5 with the help of loopback. Okay, and before configuring BGP we need to configure the link between router 4 and router 5. Okay, so let me configure the IP addresses on the link. So let me configure IP on fast Ethernet 2/0 of router 4, say no shut, and here IP address is 45.1.1.4. See, on fast Ethernet 2/0 I am using 45.1.1.4, and on fast Ethernet 3/0 I am using 54.1.1.4. Okay, IP address means lower link we are running this network 45.1.1.0, and on upper link we are running this network 54.1.1.0. Okay, so here on lower link I am saying IP address 45.1.1.4, 255.255.255.0, exit interface F3/0, and say no set here also, and IP address is 54.1.1.54.1.1.4 255.255.255.0 exit. Done. On router number 5 also, let me configure the IP interface F0/0, say no set, and here IP address will be 45.1.1.5 255.255.255.0 exit interface F3/0, and say no set, and IP address is 54.1.1.5 255.255.255.0. We can check the reachability between router 4 and router number 5. So ping, let's say 45.1.1.4. Okay, on lower link, see there is connectivity, and ping 54.1.1.4. So here also we have reachability, connectivity. Now we are going to configure BGP. First of all, I will configure BGP on router number 4. So say router BGP 65,000, and here I am going to say your neighbor is 40, not 45, right? 5.5.5.5, because we have multiple link. Neighbor 5.5.5.5 and remote AS is 65,000. Remote AS is 65,000. Then neighbor 5.5.5.5 update source loopback 1, and neighbor 5.5.5.5 and eBGP multi-hop 2. Okay, and then address family VPN v4, and going to activate this neighbor 5.5.5 activate. This is the configuration of router number 4. Let me configure R5. On router number 5 also we need to configure BGP between router 4 and router 5. So router BGP 65,001, and here I am going to say your neighbor is 4.4.4.4 and remote AS of neighbor is 65,000, right? And then neighbor 4.4.4.4 update source loopback 1, and then neighbor 4.4.4.4 eBGP multi-hop 2, and then address family VPN v4 neighbor 4.4.4.4 activate. You know, BGP neighborship will not come up. Why BGP neighborship will not come up? Because 4.4.4 and 5.5.5 are not reachable with each other, right? So I am going to configure a static route on router number 4 and router number 5 to make reachability between loopback. Okay, between loopback of router 4 and router number 5. So on router number 4 I am going to say IP route, let's say 5.5.5.5, and subnet mask 255.255.255.255, and then next hop IP address is 45.1.1.5, and there is one more link, so same IP with different next hop IP address 54.1.1.5. Okay, and on router number 5 also we need to configure one static route for 4.4.4. So command is IP route 4.4.4.4 255 255.255.255.255, and next hop IP address is 45.1.1.4, and one more next hop is, that is 54.1.1.4. Done. Now we are expecting BGP neighborship between router 4 and router number 5. Okay, so BGP VPN v4, we are getting some error here. So I think there is some misconfiguration. 5.5.5 neighbor VPN v4 send. Okay, it is sending notification message neighbor 4.4.5. okay, I think here, let me check the configuration. So run section BGP. This is BGP configuration. Let me copy this configuration, and here I am going to paste this configuration in notepad just to check what is the problem. On router number 4 neighbor 5.5.5 EBGP, okay, that is fine. Neighbor 5.5.5. Here you can see neighbor 5.5.5 and remote AS is 65,000. Remote AS is 65,001. So I am going to remove this command. I am going to say no to this, and I will add 65,000, and I will add one command here, this command 65,001. I'm going to run these two command in router BGP 65,000. Let me copy this command and let me paste it on router number 4, config t, and now I think problem is solved. Now here on router number 4 I am going to check BGP table. So BGP VPN v4 unicast all summary. So yes, we have one neighborship with 2.2.2 only, with router number 2 only. Let me check router 4, sorry, router 5. So BGP VPN v4 unicast all, sorry, all and summary. So neighbor with 4.4.4 is idle. So again I need to check the configuration of router number 4. There is some problem, guys. So run router BGP section, router BGP. Here we have neighbor 5.5.5 remote AS is okay. We need to run a few more commands like neighbor update source loopback 1. This command is removed. Router BGP 65,000 and neighbor 5.5.5.5 update source loopback 1 and neighbor 5.5.5.5 EBGP multi-hop 2 and address family VPN v4 neighbor 5.5.5.5 activate. Let me check now BGP. Yes, now you can see we have BGP neighbor, and this router number 4 have received two prefix from this neighbor from 5.5.5.5. Now if you will check BGP table, so BGP VPN v4 unicast all. So here you can see router 4 have received this network 192.168.2.0/24 from router number 5 from 5.5.5.5, and this network also 172.16.2.0 from 5.5.5.5, and router number 5 also installed two prefix, so BGP VPN v4 unicast all. It have also learned this network 192.168.1.0 through 4.4.4 and 172.16.1.0/24 from 4.4.4.4. Now router 4 and router number 5 are going to advertise these two network information to their neighbor, right? Are going to advertise this network information to router 4 is going to advertise this two network information to router number 2, and router 5 is going to advertise this two network information to router number 6. So let me take you to R2. On router number 2, let me verify the BGP table. So BGP VPN v4 unicast all, and here you can see yes, it have received 192.168.2.0, but this is only valid node based because next hop is not reachable. 5.5.5 is not reachable. If you will open this prefix in detail, let's say 192.168.2.0 and 255.255.255.0. So here you can see this network is inaccessible, right? From 5.5.5, 5.5.5 is inaccessible from here, from router number 2. So in the same way router number 6 have also received prefix of side 1 of customer A and side 1 of customer B, but those are only valid node based unicast all. You can see this is only valid node based because 4. Next hop is 4.4.4 and 4.4.4 is not reachable from here. So what is the solution, guys? Solution is very simple. We can do one thing. On router number 4 and on router number 5, let's say on router number 5, see, on router number 5 we have 4.4.4, right? Because of that, this prefix is valid as well as best on router number 5 sorry, this one 192.168.1.0. 4.4.4.4 is advertising, and 4.4.4 is reachable, right? Because we have configure one static route. So IP route, we have configure one static route, or we can say so IP route static. So we have configured this static route, right? 4.4.4.4 reachable from these two loop back, sorry, these two next hop IP address. Okay, now we can redistribute this static route in ISIS protocol, and on router number 4 again we have one static route for 5.5.5, so we can redistribute that static route in OSPF. Okay, so let me do it. On router number 5, I'm going to say router BGP, sorry, router ISIS and redistribute static. On router number 5 I have redistribute static, and now on router number 6 I am going to verify that this prefix is still valid. Yes, still valid, not best. And now you can see this is valid as well as best, because so IP route ISIS, because through this routing protocol it have learned 4.4.4.4. Okay, okay, after that, if router on router number 6 these two network are valid as well as best, then it will advertise to their neighbor to router number 8. So let me show you router number 8 BGP table. Router number 8 BGP table. So BGP VPN v4 unicast all, and here you can see router 8 have also received this network 192.168.1.0 and 172.16.1.0/24, right? And router 8 is receiving this prefix with RT value 100-100. You can check if you will open this prefix in detail, 192.168.1.0 and 255.255.255.0. So here you can see route target value is 100-100, right? And 100-100, R8 is exporting 100-100 in VRF A2, so it will import this prefix in VRF A2. So IP route VRF A2. So in A2 routing table you can see this prefix, right? In the same way, it is receiving this prefix 172.16.172.16.1.0 with RT value 200-200, and it is importing RT value 200-200 for VRF B2. So it will inject this prefix in, so IP route VRF B2. Yes, here you can see. Fine, guys. And router 8 will advertise it to router number 11, router number 12. So let me verify on router number 11 that router 11 have received this prefix or not. So IP route. So yes, you can see router 11 have received this network 192.168.1.0/24, and router 12. So IP route router 12 have also received one network through BGP, that is 172.16.1.0, and in the same way router 5 is advertising side 2 prefix to router number 4, right? To router number 4. So BGP VPN v4 unicast all, router 4 will advertise it to router number 2, and on router number 2 you can see this prefix is not best, only valid. So I am going to redistribute 5.5.5 in OSPF on router number 4. So let me take you to R4. Here let me say router OSPF process 1 and redistribute static subnet, right? After that, on router number 3, sorry, on router number 2, if you will check, so IP route OSPF. So through OSPF routing protocol it have learned 5.5.5, and now if you will check, so BGP VPN v4 unicast all BGP table, so you can see these two prefix now selected as best, right? Now router 2 is going to advertise it to router number 1. So on router number 1, so BGP VPN v4 unicast all. Right here also router 1 have received this prefix 192.168.2.0 from 5.5.5.5, and here if you will open this prefix in detail 192.168.2.0 and 255.255.255.0. So here you can see router 1 is receiving this prefix with RT value what 100 ratio 100, and VRF A1 is importing this RT value, so it will inject this prefix in VRF A1. After that router 1 will advertise it to router number 9, and router number 1 will advertise this prefix 172.160 sorry 172.16.2.0 to VRF to router number 10, and we can verify the routing table of router 9 and router number 10 also. On router number 9, let me check the routing table. So IP route, yes, here we have one prefix that is 192.168.2.0. This is other side of this customer A, right, side 2 prefix. And on router number 10 also we can check. So IP route, yes, router number 10 have also received other side prefix 172.16.2.0/24. But let me check the connectivity now. Connectivity from router number 10, sorry, router number 9, I am going to ping router number 11, means side 1 of customer A is going to ping side 2 of customer A 192.168.2.1, and say source is 192.168.1.1, and see ping is not working. Ping is not working. Now why ping is not working, right? So if you want to understand that why ping is not working, you should follow the packet. So let me guys follow the packet from router number 9. I am going to follow the packet. That what will happen when I am pinging this IP address, right? This router will generate traffic, right, where in the traffic source will be, let me write the source IP and destination IP here. Yes, here source will be 192.168.1.1 and destination will be 192.168.2.1. Okay, great. After that, router number 9 is going to check their routing table. It will check their routing table. So IP route, in their routing table, yes, there is one route available, and this network is reachable. It will compare the destination, right, with routing table, and it will find this entry. It will forward the traffic to 19.1.1.1, means router number 1. When router 1 will receive the traffic, router 1 will receive traffic on fast ethernet 2/0, which is member of VRF A1. So router 1 is going to check routing table of VRF A1, and in the routing table of VRF A1, yes, there is one route available, 192, one network available 192.168.2.0/24, reachable via 5.5.5.5, and 5.5.5 is not available here in this table. And as you know, right, this is one network is one route is available, and next hop is 5.5.5. So router 1 is going to check next hop in the global routing table, and in the global routing table, so IP route or so IP SAF 5.5.5.5 and /32. It will came to know, router 1 will came to know that it is a labeled packet. We need to assign label, right, to forward traffic to 5.5.5. What is the label? There is two label, right? It is router 1 is performing actually load balancing. You can use any label. Let's say I am using label number 305. Okay, so this will be the outer label, and there will be one inner label with VPN v4 prefix, right? If you will check BGP table, so BGP VPN v4 unicast all and 192.168.2.0 subnet mask 255.255.255.0. So router 1 have received this prefix from their neighbor with what label? With label 506. So it will add two label. One is 506, it will be the inner label, right, and there will be one outer label, that will be this one. It can be either 204 or it can be 305. Let's say router label is 305. Router 1 is going to forward the traffic to router number 3. So here label is, let's say router label is, let's say 305. 300 is 5, right? Is it correct? Yes. After that, it will forward the traffic from fast ethernet 0/0, right? It will forward the traffic from fast ethernet 0/0. When router 3 will receive this traffic, what router 3 will do? Router 3 is receiving labeled packet, so router 3 is going to check MPLS forwarding table, right? So MPLS forwarding table, and in MPLS forwarding table it will compare the outer level 300. Outer level is 305, and outer level 305 here on router number 3, sorry, router 3. So MPLS forwarding table, outer label, it will compare outer label with local level 305, and remote level is, outgoing level is 404. It will swap the label to 404 and it will forward the traffic to 5.5.5.5. It will exit the traffic from fast ethernet 1/0, and next hop is 34.1.1.4, means router number 4. So it will swap the outer label from 305 to 404. 404, right? Let me check. Yes. And after that it will forward the traffic to router number 4. Now when router 4 will receive the traffic, what router 4 will do? Router 4 is also receiving labeled packet, so it will check MPLS forwarding table. So MPLS forwarding table, and in the MPLS forwarding table, local label is, here you can see local label is 404 here. For this label there is no label, outgoing label is no label. Guys, there is some difference between no label and pop the label. No label means, no label means remove all label, and pop the label means remove only top label, right? So here no label for local label 404, outgoing label is no label. That means router 4 is going to remove both level, inner level as well as outer level, and after that it will forward the traffic to 5.5.5.5, 5.5.5 from fast ethernet 2/0 or from fast ethernet 3/0. And when router 5 will receive this traffic, what will happen? See, on router number 5, router 5 have received unlabeled packet. Here we have problem. Router number 5 is going to check global routing table, because it have received unlabeled packet. It will check show IP route. In the global routing table there is no any route available for 192.168.2.0 network. For 192.168.2.0 network, you can see there is no any route available for this network. So what router 5 will do? Router 5 will simply drop this packet, because route is not available. So actually router 4 should not remove all label, it should remove only top label. So actually, here we are not running MPLS, so router 4 don't have any label for 5.5.5.5. so that is the reason why router 4 is removing all label. So here actually on router number 4 and on router number 5 we need to configure a static label. On router number 4, let me show you how we can configure a static label. On router number 4, simply we can run one command, MPLS static binding, and after that we are assigning label for IPv4 prefix, so IPv4, and then the network 5.5.5.5, 5.5.5.5, then subnet mask 255.255.255.255, and then output, and then next hop. So next hop is 45.1.1.5, and we can say implicit null, means we are assigning implicit null label for 5.5.5. then it will remove means top label only. Okay, and there is one more link for same neighbor, so I am going to say I am running same command with different IP address as well, because there is one more IP address to reach 5.5.5, that is 54.1.1.5. That's it. And now if you will check MPLS forwarding table, so MPLS forwarding table, now you can see when router 4 will receive any traffic with label 404, it is going to pop the label. Now there is pop the label, not remove. No label. No label means remove all label. Pop label means remove only top label. So this time router 4 is going to remove only upper, means top label, and there will be inner label, and then it will forward the traffic to 5.5.5.5. And in the same way we have to configure a static label binding on router number 5 also. So here also I'm going to say MPLS static binding, and then IPv4, and for which network, 4.4.4, mask 255.255.255.255, and then output and next hop IP address is 45.1.1.4, 45.1.1.4, and say implicit null. And for this neighbor also, for next hop 54.1.1.4, right? And now let me check again the connectivity from router number 9. Is ping working now from router number 9? Still ping is not working. So now what is the problem? Now problem is, now let me follow the packet once again. Okay, so again source IP is this one, destination IP this one. Router 1 is going to add the label. Which label router 1 will add? This label. This is the outer label 305, and inner label will be this one 506. So there is two label 506, and there is one more label that is let's say 305. After that router 1 will forward this traffic to router number 3. Router 3 is going to swap the label. Router 3 will check their MPLS forwarding table, and in their MPLS forwarding table it will compare top label with local label. So local label is here, local label 305, and it will swap the label to 405, means outgoing label is 405. Guys, local label is used to receive the traffic, as you know, we discussed many times, and outgoing label is used to forward the traffic. So outgoing label is 404, so it will swap the label, it will remove this label, and it will add 404, and after that it will forward the traffic to router number 4. When router 4 will receive this traffic, this time router 4 is again going to check MPLS forwarding table. In MPLS forwarding table it will compare this local label 404, and remote label is, means outgoing label is, pop the label, it will remove the outer side of, means top label, and it will forward the traffic to 5.5.5. it will pop this label, and it will forward the traffic with one label to router number 5. This time router 4 is forwarding the traffic with one label. So router 5 will receive labeled packet this time, right, and label is 506. So router 5 is going to check MPLS forwarding table. So MPLS forwarding table, in so MPLS forwarding table it will compare the label. Local label is 506, it will swap the label to 804. It will swap the label to 804, and it will forward the traffic to, again you can see it is going to forward the traffic to VPN v4 prefixes, right? It is going to add one inner label, right? So it will open this prefix in detail, it will find one label with prefix, because with this prefix there will be one label in BGP table, right? So it will add that label in inner label, and this label in outer label. Okay, and after that it will forward the traffic to their to 8.8.8.8 to 8.8.8.8. Okay, so what is happening here? What is the problem? Issue is, guys, here I have configured BGP between router 4 and router 5 through through loopback interface. So MPLS BGP forwarding command is not enabled on interface fast Ethernet 3/0 and 2/0. In previous video, in last class, in previous video, we configure router BGP 65,000 neighbor 45.1.1.5. So automatically BGP have added one command there, MPLS BGP forwarding. But today I have configured BGP through loopback interface. So here we need to configure manually, we need to run this command MPLS BGP forwarding on fast Ethernet 2/0 and fast Ethernet 3/0. Let me do it and then I will check again connectivity. On router number 4, first of all, on router number 4 I am going to use interface range F2/0 and F3/0, and here I am going to say MPLS BGP forwarding, MPLS BGP forwarding. And on router number 4 also you can run this command, interface range F0/0 and F3/0. Here I am going to say MPLS BGP forwarding. Now you can check the connectivity. I think it should work. Ping should work now, and yes, now you can see ping is working now, because side 1 of customer A is able to ping side 2 of customer A. And in the same way, let me check the connectivity of customer B, side 1 and side 2 also. Ping 172.16.2.1 and source is 172.16.1.1. Yeah, ping is working. Okay, so this is the last video of inter autonomous MPLS VPN option B. Hope this video is helpful for you. That's all for today. In next video we will discuss inter autonomous MPLS VPN option 3, and then you can compare option A, B and C. Okay, so that's all for today guys. Thanks for watching. Bye bye.